application problem that related to right triangle trigonometric ratio. Let's go over a couple of definitions. If an observer is looking at an object, then the line from the observer eye to the object is called a line of sight. So let's say here you're standing and let's say we have a tree and I'm bad at drawing. So from the distance from your eye to the tree, this distance here is called a line of sight. If an object is being observed is above the horizontal, then the angle between the line of sight and the horizontal called the angle of elevation. So let's say if you look it to the top of the tree, this direction, this angle here called the angle of elevation. So angle of elevation you look up. If an object being observed is below the horizontal, then the angle between the line of sight and the horizontal called the angle of depression. So this angle here, angle of depression. Think about this, if you're looking down, you sad, so you depressed, so that angle is angle of depression. Now, here's get that picture again. Let's take a look at the first example. And for all this problem here, we want to round the answer to the nearest whole number. Okay. A giant redwood tree casts a shadow of 532 feet long. Find the height of the tree if the angle of elevation of the sun is 25.7 degrees. So as here you can see, well, the ray of the sun hit the top of the tree before it go to the ground. This angle is 25.7 degrees. We make a triangle that involves the height of the tree, the distance from where the shadow of the tree, and the hypotenuse is the rate of sunshine. Okay. So here we can see that, well then, tangent of 25.7 degrees is equal to the opposite divided by adjacent, that is 532 feet. So 8 equal 532 times tangent of 25.7 degrees. I recommend you to put all this into the calculator and then round the answer at the end. Don't try to calculate each thing separately and multiply. You get that round error that way. Okay, so calculator again. 532 times tangent of 25.7 degrees. And to the nearest whole number, this tree is 256 feet tall. Model and need to find the height of a building. From a given point on the ground, find that the angle of elevation to the top of the building is 74.2 degrees. Okay, so let's try to recreate this problem. Let's draw this out. So here's the ground, and here is the building, and let's call this is the line of sight. So from a given point on the ground, find that the angle of elevation to the top of the building is 74.2 degrees. Then walk back 35 feet. Okay, so let's say this distance here is 35 feet. From the second point, the angle of the elevation to the top of the building is 51.8 degrees. And we want to find the height of the building to the nearest foot. You can see here we have two triangles that involve. We have this small triangle and we have the bigger triangle here. We want to use tangent to figure out what is the height of the building. So in the small triangle, we have one angle that is 74.2 degrees and we don't know the height of the building. Well, let this distance here from the first point to the base of the building be x. Then I can say that tangent of 74.2 degrees is equal to h divided by x. In the second triangle, the larger one, tangent of 51.8 degrees then equal h divided by 35 plus x. What I can do is I can solve for x in the first equation and plug it into the second equation to get one equation of one unknown, that is h. And so I'll go ahead and solve for x here. Then x equal h divided by tangent of 74.2 degrees. I will substitute this value into the second equation to get tangent of 51.8 degrees equal h divided by 35 plus 8 divided by tangent of 74.2 degrees. On the right hand side, I will simplify this complex fraction by multiplying the numerator and the denominator by tangent of 74.2 degrees. By doing that, I get the right hand side become 8 times tangent of 74.2 degrees divided by 35 tangent of 74.2 degrees plus 8. So let's write this equation again together. Tangent of 51.8 degrees equal 8 times tangent of 74.2 degrees divided by 35 tangent of 74.2 degrees plus 8. My goal is to solve for h in this equation. And I will do this as follows. Distribute. Subtract both sides. Factor out 8. And we'll divide both sides. And I will plug all this into our calculator as it is, and we get the answer in the end. Again, we don't calculate this individually because you end up with rounding error. So here's our numerator, 35 tangent 51.8 times tangent 74.2, and that is the numerator. Careful with the parentheses. Divide by the denominator, tangent of 74.2, tangent of 51.8. So the height of the building to the nearest foot is 69 feet. Take a look at the second problem. The third problem, I meant. A plane is flying within sight of a gateway arch in St. Louis, Missouri, at an elevation of 35,000 feet. The pilot would like to estimate her distance from the gateway. She finds that the angle of depression to a point on the ground below the highest point of the arch is 22 degrees. We want to find the distance between the plane and the arch, and we want to find the horizontal distance between the plane and the arch. So here we got a plane. And here we get kind of an arc, that point below the arc. And here's the ground. The angle of depression from the plane to the point beneath the arc is this angle, and that is 22 degrees. This angle here is 22 degrees. Okay. This meant that this angle here is 22 degrees as well. Okay. And we want to find this distance in part A, and we want to find the horizontal distance. This is in part B. We are given that the plane is at the elevation of 35,000 feet. Okay. So part A, I can say that, well then, sine of 22 degrees is equal opposite divided by the hypotenuse. So then this equal and with the calculator I can figure that out pretty easily. So that distance is 93,431 feet. In part B, well, I want to solve for x. So cosine of 22 degrees is equal to 35,000. Oops. Should I use cosine of 22 degrees? I probably don't want to do that, because if I use cosine of 22 degrees here, then it will involve the answer that I got from part A, where D is the hypotenuse. Now if I calculate the hypotenuse wrong, then I will get the answer for part B wrong as well. So rule of thumb, we do not want to use what we just calculated if we can help it. So how do we get around this? I can say this, well then tangent of 22 degrees is equal opposite divided by adjacent. So then x equal to 35,000 divided by tangent of 22 degrees. And that is 86,628 feet. Now, another thing of fun stuff here is to calculate the area with a triangle using the trigonometric ratio to come up with a new formula to calculate the area of a triangle. Consider the triangle A and B. Let's calculate the area of the triangle based on the fact that the area equals 1/2 base times height. Okay, so let's say we are given this triangle, we call that ABC, and this is the height. And let's say I'm given the measurement of this angle theta. Okay, so area equal 1/2 base times height. If you're looking at this here is a right triangle, right? Let's go ahead and see that we are the measurement of the side that opposite with the angle B. Let's call this is small b, this is small c, and this is small a. I can see that, well, look, I can say that, well, side of theta is equal h divided by c, right? In this highlighted triangle here. So then h is equal to c times side of theta. Okay, so in this triangle ABC, the area of the triangle area equal 1/2 times base, well, the base is B, times the height is C, side of theta or side of A, the angle A. Okay. Now, that is the formula that we just came up with for an acute triangle. Let's say this is the same for the obtuse triangle. In the obtuse triangle, A, B, C, the height of this triangle is this one. Okay. So let's consider this right triangle. And let's say we are given this angle theta, or that's angle A. This is our C, small a, and small b. The area equal 1/2 base times height. That is 1/2 times the base is b, the height h. So here we can see side of theta is equal h divided by b. So h equal b sine theta. Excuse me, divided by c. So h equals c sine theta. So times c sine of theta. Or theta is the measurement of angle A. This is 1/2 bc sine of the angle A. Okay, so note, so here that you can see the area of the triangle with the side length of A and B with the included angle theta. The included angle theta is the angle that in between the side A and B, or in this case side A, the angle A, and you are given the length of B and C, then the area equal 1/2 BC times A. I can write this in general. The area of a triangle with the side length of A and B would include angle theta is 1/2 AB times side of the angle that in between. Let apply that to a couple of our problems. Find the area of a triangle given the side of 7 and 9 included angle is 72 degrees. So then the area equal 1/2 7 times 9 times side of 72 degrees. And let's put this into our calculator. So 1/2 times 7 times 9 times side of 72 degrees. So the area of this triangle is 29.95 or 96. Let's round it to 2 decimal place. So 29.96 unit square. An isosceles triangle with an area of 24 centimeters square, and the angle between the two equal sides is 5 pi over 6. Find the length of the two sides. Okay, so let's see, what is 5 pi over 6? 2 degrees. That is 180 divided by pi. And this, we simplify this. Pi is by 6. So 180 divided by 6 is 30. So this angle is 150 degrees. Okay. So you have an isosceles triangle with this angle is 150 degrees. And then this side here is equal A and A because it's an isosceles triangle. So we area equal 1/2 A times side of 150 degrees. That is 1/2 A squared times side of 150 degrees. Okay, we are given that this equal to 24. This means that A squared times side of 150 degrees is equal to 48. A squared is equal to 48 divided by side of 150 degrees. And so A equal, and we want the positive part. So let's go ahead and try this out. So A squared then equal 48 divided by side of 150. That is 96. So A squared equal 96. A equal to square root of 96. Okay, and we need to simplify that rational. And this equal 4 square root 6. Here I want to calculate the area of the shaded region in this picture. Well, recall the area of a sector is equal to 1/2 r squared theta, and theta is in radian. I can calculate the area of this whole sector, then subtract with the area of the triangle. Okay, so area of the shaded region equal area of the sector minus the area of the triangle. So first thing first, let's go ahead and rewrite theta equal to 120 degrees into radian. So 120 degrees into radian. And that is 2 pi over 3. So the area of the sector equal 1/2 times 7 squared times 2 pi over 3. the area of the triangle, this is a isosceles triangle, so that is minus 1/2 7 square times sine of 2 pi over 3. Simplify this a little bit, that is 49 pi over 3 minus 49 over 3 sine of 2 pi over 3, that is root 3 over 2. So then here we have 49 pi over 3 minus 49 square root 3 over 6. Now we can leave this as the exact answer like this, or you can calculate this out using the calculator and round to however that's as many decimals as needed. The next one, we want to find the area of the parallelogram. The one thing about the parallelogram is that the area of half of this parallelogram here, in this case, is equal to the area of this portion. Okay? So when you draw a diagonal in the parallelogram, you split that into two equal regions. I can calculate the area of the parallelogram by first calculate the area of the small triangle and then multiply it by 2. So area of the parallelogram equal to times the area of the triangle, that 1/2 times 41 times 27 times sine of the angle 159 degrees. And that is 41 times 27 sine of 159 degrees. And the calculator will tell us what we want to know. 41 times 27 times sine of 159. And that is 396.71. And this is centimeter square.